Hello everyone, True Zero Emissions here. Okay, so I was thinking about this idea of, we've been talking about the blotch wall, Don Smith rotating separator coil, and I have my pages a little bit mixed up here. Okay, this is one of the designs we were discussing, I was showing you. I'm not sure if this is the exact one or if this is a different one. Anyway, this is one of the ideas where I have a magnet. So this is a variation, I'll call it a variation of the Don Smith, sorry, just setting my phone to do not disturb so that the video won't get interrupted. This is my understanding of a variation of a Don Smith rotating separator coil. Excuse me. I really hope my voice is not going to keep interrupting me. It's only when I'm making this video, right? How does that work? Okay, the Don Smith rotating separator coil. This is my understanding of a variation of that. I'm just kind of making up something with my imagination of how can I interrupt, how can I move, how can I say this, how can I flux a magnet? How can I flux the magnetic field of a magnet, right? Which is what Don's doing. He's fluxing, he literally said he's fluxing the magnet by having two of these. Don had, this is one magnet right here, one long magnet, right? South and north. Imagine two of these, so one here and one here, and then interrupting the field between the two. So when that field is not interrupted, this is read as one continuous magnet, and then when the field's interrupted, this becomes a north and a south, and a south and a north, right? So I'm thinking, what can I do that would be a variation of that? Because Don was getting, at a very small area, I think a 2-inch diameter, approximately by 4 or 5 inches long, regular neodymium magnets, okay? Ordinary neodymium. But the polarity has to be north on one side, south on the other. Not like north on this side and south on this side, right? There's different kinds of magnets. One side has to be south and one north, right? So this is south, this is north. And then it has to be the opposite. The one that's near it has to be the opposite. So if this is north, this would be south next to it. And then north would be over here again, right? Now, when the fields, when they come together close enough, right, leaving a space between them, but when they're close enough together, the magnet, like if we have a magnet detector that reads the magnetic field, they sell them on Amazon. I can show you one. Here's one right here. See how it says north or south? When you hold that, it's looking for that signal. And there's the name of this one. I bought this on Amazon. They're probably available on Google as well. It's just called General Twist to Open. And this is one that it appeared similar or identical to the one that John Bedini was using. I also have this one, but this one's not as easy to know where the neutral is. Because, see, I can read north with this one, right? I can read north. And then here, there's south, right? But where's the neutral? Exactly. See this, so neutral is, I'm just kind of guessing, see? It's like right here, right? But I want to know exactly where it is. So that meter will help me with that, because when it stops beeping, there's no north, no south there. And to me, that's good enough for me. Now I have next to this something else I was studying in the past, which is a G-field generator, right? It's called a tachyon. I called it a tachyon G-field generator. I also noted down 27 to 100 times the speed of light. This is supposed to be a spaceship motor. In theory, it's supposed to be a generator, a drive, part of a drive system or part of something significant to a spaceship, okay? Imagine 27 times the speed of light or 100 times the speed of light. Now, I've looked at this and I've studied this and I've slept with this underneath my pillow because it said that can help us absorb things. We can learn in ways we don't presently are not popularly understood, but it's been proven that if you sleep with books underneath your pillow, or sleep on books, and I've been falling asleep on books my whole life, not even knowing this, but I would just fall asleep reading a book, and then I'd wake up and be like, how come I know all this stuff in the book? Like, it seemed familiar to me. So I believe that is possible, but we're also connected to the, what is it called? The resonant morphic field of infinite intelligence. It has many names, but everything's interconnected throughout all time and space. So all knowledge is available to us all the time, right? I imagine that the way to access it is kind of like just by focusing on something. Like when we want to learn something, it's kind of like me studying this. I'm starting to get ideas. I don't know where this came from, this idea, this variation. I was just thinking, how else can I do this? And then I saw an image of putting metal here and wrapping a coil around it. And then I just drew it out. Right? That's where it came from. And we just call it the imagination, but I don't know. So anyway, this G-field generator, let's see what it's doing here. So I was noticing that Dawn has us wrapping a coil around a magnet, right? And we're calling this extracting energy directly from a magnet by just fluxing the magnet, right? And study Felix Bloch, B-L-O-C-H. Felix Bloch, Nobel Prize winner. And this is called the Bloch wall, B-L-O-C-H. And Felix, I want to study everything I can on that and learn everything I can about that Bloch wall, that center part, that neutral part. Anyway, I think what's happening, I'm just going to use Dawn's words, and Dawn says when we're fluxing this, I'm kind of looking at it like we're moving this neutral area. Because if we put a magnet against this, right, a same magnet up against this, north, south, so they attract, right, and they're touching, this becomes that right there. The neutral area moves to right here. Isn't that beautiful? So if we could touch that together and then move it away, and then touch it together and move it away, this would shift from here to here. And when it shifts, when it goes from here to here, when it does that, what do you think happens? Dawn was getting out of 2-inch by 4 or 5-inch long neodymium magnets with the north on one side, south on the other. Nothing special, just regular neodymium magnets. And my understanding is we can use any magnet. Now, I haven't done any of this myself. I want to, and I will. I plan to. But I'm just sharing the thought experiments. I'm sharing the journey to getting to the experiment, right? And this is what I request of all experimenters and all inventors and everyone in the world, to share the theory building up to where you're going. Share that journey. You don't have to share, and I always say this, you don't have to share your exact invention, like your specific design that you want to patent, but we have to know the theory. Otherwise, when your project comes out, if no one believes it can be done because it violates the laws of physics, which really is what the laws of physics are, is theories and principles that are always evolving and always changing and always being extended, right? Like, look how many different electrodynamics there is. Tom Bearden talked about O1, O2, and O3 electrodynamics, right? It just keeps going. So I was thinking if we put an electromagnet here, so this is not magnetic, it's not a magnet, but then we put a energy through it, right? AC or DC or both, have two coils, have an AC and a DC coil pulsing intermittently, or both of them pulsing at the same time. And that makes me think of the John Searle SEG, Searle effect generator. I don't know exactly how that one worked, but I know they used a little bit of AC to make pinpricks of, it was described as lots of little pinpricks of flux fields everywhere when you use AC, right? Just lots and lots of flux fields. And I want to see this flux field moving on this magnet, right? That's what I'm looking for. That's what I'm thinking. Now, even though I said I'm looking for that, what else is there? Is there something else there? Will I find something else that I wasn't even thinking of or looking for? Can I notice what else is taking place here? And will I get watts out of this? Don, and I was beginning to say that Don Smith said he was getting 50,000 watts, 50 kilowatts, from just 2 sets of magnets. He had both magnets wrapped with wire, the same wire, So they both had a wire going around and then over here and then wrapped around. And then he was just interrupting that flux field, or he was fluxing it. I don't know if you want to call it fluxing or what words you want to use, but switching these two magnets, right? Imagine the same magnet here, over here, switching them from being one magnet, right, with a little space between them. And I still have to test that. How much space? Because I thought magnets had to touch to be one magnet. But according to Don's work, if I understand correctly, and I'm interpreting and paraphrasing, when we pull that magnet away, especially if it's neodymium, now they're going to want to come together. So what do we use to hold them apart, right? But according to Don's research, if we pull that away a little bit, how far can we go away? It looks like he has at least an inch there, but I don't know exactly. We can go apart a little bit, and it'll still read as one continuous magnet. So I'm kind of curious, how far can we go away, and it still reads as one magnet, right? And then at what distance does it separate into two magnets? And then go in a little bit so they still read as one, and then interrupt that field between the two sets. And then this shifts from here to here, and it does it on both magnets. So this magnet and the other magnet would both shift. It would go like this. This would go here, and the one on this magnet, that's the same magnet, but this side would be south, right? It would also go there too. I think it would go that way, like this. Boom. Yeah, it would. It would go this way. Boom. It would go like this. Boom, boom, boom. And some people describe that as pumping the energy, right? Like John Bedini, I think, described it that way. Like you're just pumping the energy from the 0-point field. Now, we don't all have to agree where the energy is coming from. We can say it's coming from the magnet. We can say the sun is making electron pairs, large and small electrons, which pair up automatically by themselves. And then there's the Dirac, D-I-R-A-C. Dirac, S-E-A, a sea of electrons. Dirac sea, like an ocean, right? The Dirac sea. So are we shaking electrons loose from the Dirac sea holes in space, right? And do we call it space? What do we call it? So I don't need us to all agree on anything. All I need to do is see what the energy is doing. That's all I'm looking for. The way it's described and the wording is wonderful. I think it's great, but I'm not going to get stuck on words and on everyone needing to agree on something. I just want to see, am I getting some power out of here? Like I said in the past, if I can get 25 watts from this, I'll be pretty happy. Now, people are often going to be looking for how many watts does it take to interrupt that field, right? So if it's taking 100 watts to interrupt the field by running an electric motor that spins, and it takes 100 watts, and we're only getting 25 watts out, I think a lot of people would be happy with that still, because we're kind of expecting that, right? So it's just a fun experiment, and we're getting less energy than we're putting in, and that would probably make a lot of people happy because that's what they want to see, right? But there's also a lot of people that want to see us accessing that energy that John Wheeler and Richard Feynman, and again, Richard Feynman is a Nobel Prize winner, right? Just like Felix Bloch of the Bloch wall research. So we're already talking about 2 Nobel Prize winners. And then people can make fun of that and go, oh, well, that was a mistake. They should have never got Nobel Prize, or one of the... I read that sometimes, not about those gentlemen, but sometimes someone will get a Nobel Prize and then people will write on the internet that they should have never got that. It was a mistake, and it's the big joke. But people say that about everything, and all the great inventions that we have right now, including the airplane and anything else, all the other ones, all of them. It's documented that it's always made fun of in the beginning. And even when it could be out and popular, like not popular, but out in public and proven and everything, and people still could be making fun of it. And then at some point it switches over to, oh, of course, it's obvious, right? So there's famous quotes and sayings about that process, how it switches over. And then everybody kind of forgets, and everyone that was speaking against it, so people aren't necessarily angry at the people that were putting it down and making fun of it, because that's kind of expected as norm, right? Like, oh, well, that's normal. We know that people are going to make fun of things. But wouldn't it be nice if the norm was just to encourage people to experiment, as long as people aren't hurting themselves? Although, when people wanted to fly the first airplane, I've read articles where they were saying no one should be allowed to even attempt to fly, and if they're even thinking about it, or they try to do it, they should be put in the mental hospital, because they're trying to cause harm to themselves and to others. And so, some people agreed with that, but most people didn't agree with it. Most people said no. We must experiment. We must try new things, and we must try to fly. If people want to try, they can try. So that has prevailed, and that's the reason we have airplanes now, and we have flight is very common. Thousands and thousands of flights a day, if I understand correctly. So going back to this experiment here, yes, so it's like, such as myself, I'm excited whether something works, or whatever the result is, I'm happy about it. I'm excited about it because I'm learning. But I am interested in what Don had said as well when he says 50,000 watts, which 50,000 watts, which is coming out of the wires. And I don't know how thick the coils were, because Don always says that, you know, what he's showing in pictures is just kind of like a simplified version of what he actually did. So even though he showed a picture and the picture shows like 10 gauge wire, or maybe, I don't know if it's 12 gauge wire, and it's regular wire, I don't even think it's magnet wire, and it's wrapped around, I think it's stranded wire, but it's wrapped around the PVC pipe, and inside the PVC pipe is the magnets, and it's wrapped around just one time, not even many layers, just one time, right? One depth, right? One I don't know what you call it, but just one layer, I'll call it. So once, and then once around the other magnet, right? So I don't know how many feet of wire that is, but was he getting 1,000 watts in that wire? Or is he saying this is the simplest version of this? So, you know, you have to modify it yourself, upscale it, right? So does that mean we also have to upscale the magnets and upscale the wire, like use a lot more wire? I would be interested in trying it as it is with smaller magnets, and then using the wire, one row of wire, right? And then the same wire coming over, one row of wire, and then go into the system that he says to go into, which I think is a I don't recall what it was. I don't know if it was a capacitor and then a transformer, but I would want to just connect the wires to a full wave bridge rectifier and then to a voltmeter, and then if I'm not seeing anything, put it into a capacitor to see if I can store some energy there, and then see if the capacitor is gaining any voltage there, and then try putting a load on it and see what happens. I would try those different steps, and also looking back in the book and seeing exactly what he said. So I have it here going into a full wave bridge rectifier, and then into a capacitor, and then to a battery, and then I could test that by putting a load on it, right? But just so on this one, it would be charging this field up, so this would just stay there one place, and I would be switching the magnetic field, the electromagnet, we call this an electromagnet, on and off, on and off, on and off. And see how I said what did I say there? AC or DC, test both. And that's because I'm thinking of John Searle, how I think he specifically said they had a little bit of AC in there to help have more flux fields, right? So I don't know if that's necessary, though. It's probably wiser to just do what Don Smith did in the beginning, which is he just had two simple magnets. So in that case, if I'm making this an electromagnet, this would be the south on this side of this metal right here, this iron, this ferrous metal, which a magnet can stick to, but it's not magnetic at the moment until we turn the electricity on, right? And I think we put DC into this to make this an electromagnet. I think that's what we use, but confirm that for yourself. And then switching that on and off maybe once a second, 20 times a second, 60 times a second, on and off, on and off, on and off with a square wave, right? So on and off, sharp on, sharp off, sharp on, sharp off. So just like a square wave, right? Can a pulse width modulator work with that at a very low setting? I don't know. It might be, Robert was telling me the frequency might be too high. And Robert was talking about using a 555 timer with it. He said, you know, Robert never has time to make the circuits. He's always so busy maintaining Robert's doing the maintenance, you know, all the time. So he seems to be way behind, years behind on his maintenance work. So I might need to look for more people to help me make 555 timers and stuff like that to power this. Or unless I could find something that already will power this, something that already has a 555 timer in it, where I can just connect it to this and turn it on and off, or connect the timer to an amplifier of some kind, and then allow this to switch, turn this into a magnet and turn off. But then I thought, and I think I made a video of this as well. Oh, this is another variation of that. It's the same thing. I drew a transform here, but let me finish my other idea first. I think I was going to say, yeah, this was the most recent one where I said, what if I, instead of using an electromagnet, I just use magnets? North, south, right? And this spins. So if this is spinning and this stays still, but this turns in a circle, when the north passes this, right? Because I want to make this thing, I want to make the flux field move in this. I want to make the block wall move. I think that's what I'm trying to do. But I just want to make it, as Don said, as Don Smith said, you can look at Magnetic Resonance Energy Crafting Systematic Index book by Richard Friedrich. And he has a YouTube channel, Rick Friedrich, and he has a website called r-charge.com, I think it is. But just if you go to Rick Friedrich YouTube channel, you'll see links to his website, and then you can find the book there as well as on Amazon. I bought the book directly from Rick's website when it first came out, and I read the book many times. So, and I reference it all the time. So what I'm thinking about here is if I spin this, so I'm thinking, what's another variation, right? So if I spin this magnet, when the north comes here, it's going to pull the flux fields this way, right? It's going to pull the neutral area this way when the north is here. And then when the south comes around, I think it might push it this way, right? I think that's what's going to happen. So I'm imagining this kind of fluxing back and forth. This is a magnet. This is a neodymium magnet or some kind of magnet, a bar magnet of some kind, or just any magnet. And I want to get the flux fields moving. That's what I think I want to happen. I want to see if it does anything. I mean, it shouldn't be hard to figure out if it's doing something or not. Like my friend Cameron was saying, he's like, you know, how do you just test it to see if it's going to do something, right? And I tried a small version test of this with those little pickup coils from an electric guitar, and I was getting voltage from that. I was putting 1 volt in and getting 12 volts out. But I also don't know if I was putting a lot more current in at 1 volt in, and then the current, it was just acting as a transformer, right? Like a step-up transformer, stepping the voltage up and the current proportionally going down. But in this case here, with this fluxing this field here, I'm thinking, how can I do this, right? So I found this rotor here, which was from a motor, from a lawnmower motor. These are magnets here, north, south, all the way around. And I was thinking, if I spin this with another motor, if I spin this, and I have that braced mounted against something, right? Even where it is right there, even if I mount it like that, right? Like, what if I just mount that, like, one screw into the wood there and one into there? And, well, I'd want to put a top on it. I want it to be very stable. I don't want this to be able to come out, right? Because right now it can, yeah, it probably could come out. It's not coming out. I was trying to get it to come out and it wouldn't come out. But I don't want it to be able to come out. I want it to be able to stay there for real securely. So I'd want to put the top part of this on, and then maybe cut out a, like over here, like turn it like this, and then cut it out in an area here in both sides of the other side, cut it out, and then stick the other magnet in there close to this, and then have that mounted and braced real solid, which is be this magnet. And then as the magnet's spinning, so this just shows a north and a south, whereas that magnet has north, south, real quick, right? So it's going to be fluxing this thing back and forth really fast. I don't know if that's ideal or if it's better to have one magnet or two. I don't know, because sometimes less is more, right? Look at John Bedini's systems where he just had, you know, like the pendulum. I think it just had one magnet passing the bottom, like boom, 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 boom. And he was charging like lots of batteries with that. And I imagine the magnets were very, very strong in that instance. And he probably had really big coils in there with iron cores. I'm not sure, though. That would just be such a fun toy to be able to buy, like a small version of that. I think that'd be a lot of fun if that could be like a toy that people could make for themselves and then bring to school and stuff and show on Share Day. I think all this stuff is fun to share on Share Day, and I think it's fun to share about the 0-point field having 10 to the 40th times more power than the energy in the material universe. I think it's fun to share things like that the universe, every particle in the known universe and unknown universe recharges itself or is recharged by the 0-point field at 10 to the 120th times a second. That's 1 with 120 zeros times a second. That's super, super fast, right? Because our power runs at 60 cycles per second, and the universe recharges itself at 10 to the 120th cycles per second, right? That's super, super fast, you know. So what happens when we start getting circuits that can move at those speeds? And maybe we already have it in radio frequencies kind of things. Maybe we have some of that in the super, super high frequency areas. But I do think when that happens, there's going to be some amazing things that'll happen. I think we'll be able to probably teleport through space and kind of show up anywhere in space, anywhere in time. I think that happens when we start when we start moving at the frequencies that the universe replenishes itself at, I think a lot of things become possible, which is why I changed the name most recently of the Thomas Bearden Energy from the Vacuum series. I updated it to Thomas Bearden Learn to Engineer Reality, because that in that series, Tom Bearden talks about learning to engineer reality. And that comes from students. It's not going to come from the teachers. The students are going to teach the teachers, and the teachers will begin to teach that once they understand it. But I think the teachers and the students can collaborate together, right? And the best teachers are open to new ideas. They realize we don't know everything, and they're flexible on learning, even though there might be specific rules within which they present information. The teacher can never control what the student brings to them, and the teacher must work with the material the student brings to them to some degree, right? Because there's always room for the new material, right? I think that's true. That's the way it's been explained to me. But again, every school could be different, and we have to find the schools that are a good match for us, right? We have to find where we kind of would fit in with our approach to thinking and learning. So then if we find a match, that's the one, I guess, right? And they say, like, the famous name schools might not always be the best fit for everyone, right? It could be for many, and it could be, most of the time, but there could be times when it's like, oh, well, I can get a great education from a school that's not as well known or as expensive, but it's a good fit for that person, right? And people talk about this too. This is one of the things that are discussed when people are thinking about what school to go to. So going back to the system here, in this experimental system, which we'll call kind of like a thought experiment, and also a variation. I'm thinking of it as a variation of, and I don't know if it qualifies as a variation, but I'm thinking of it as a variation of Don Smith's rotating separator coil. So I'm going to show you what I was thinking about with the transformer. So I was looking at a transformer. I was thinking about a transformer, like a microwave transformer, right? It has I think they call it L1, L2, or they call it the primary and secondary. I think these are the words that are used. And this may be inaccurate the way I'm writing stuff here, but I just put like 120 volts input, and then I just made up a number, and I just said like 10 volts output, right? So, and then I put ferrous iron, so the iron's here, and then there's two coils, right? So if we're putting in a certain amount of voltage and we're stepping the voltage up or down, the current or the amps always moves with that in proportion, right? So we still have the same watts, right? We still have the same available watts. If we put a certain amount of watts in, which is volts and current, then we'll get the same amount of watts out, or possibly less, right? So now I was thinking to myself, okay, we have iron here. Do we have an electromagnet? Because we have iron. First of all, will a magnet stick to this iron? And I think it will. And then I can ask myself, well, how come we're not getting more energy out than we're putting in, right? We're pulsing this iron, and the iron's for one question I was asking myself is the iron becoming polarized? For the moment it's on, when that pulse hits it on the input, does it have a polarity, right? Does it have a north and a south? Or is there flux fields moving anywhere in the magnet? And then if those flux fields are moving across the second coil, why am I not getting more energy out, right? I was just thinking about this. Now, again, these are beginner thoughts, and a lot of people might laugh at this, but I'm trying to just have thought experiments, and I'm trying to think as a beginner, which is easy to do because I am. But I read a lot too, so that, that it's fun to have the beginner mindset and approach, like the openness of a beginner, combined with having read a lot as well. But I do not make any claims to have any great knowledge about anything. My only claim that I have, and it's not a claim, it's a statement, is that I love to share my experience, and I think that's important. And I think that's the expert. If we want to say there's an expert and there's a neutral person in all of this, I think what that is handing to YouTube or to social media, but I think YouTube's the place, handing it in the form of a video, something that, what I mean is creating a way of sharing visually, whether it be in writing, in every way possible, drawings, something that everyone can replicate, that they can see for themselves and create for themselves. And to me, that's the neutral existence, right? That's the expert. Because if we just say, well, that person's the expert and whatever they say, I'm going to believe it, that's not really helping all of us experimenters and people that want to see what something does for ourselves, right? So that's why it's important that a lot of people will say, oh, well, everybody knows free energy is real and it's obvious. It just costs so much, right? It just costs so much money to make a free energy device. It requires such specialized materials, right? That costs like so much money, and not everybody can do it. And that's the challenge for part of the challenge of existing in thought is, and creativity and creation, is to make something so simple and so accessible that, like I think of the GEET, GEET, Global Environmental Energy Technology. That's a field reformer, and it's many other things as well. Many good things, all good things. Like anything, it could be used for bad, but we don't want to use our tools to cause harm to people, right? I don't want to use this tool. This is not for hurting people. This is for fixing things, right? So, of course, all things can be used, many things can be used for good or bad. You have to choose what you want to do with it, right? So this channel is all about the good, okay? We focus on the good, right? So when I tell people science fiction is science fact waiting to be discovered, which is a paraphrase of a lot of different books that I've read and just material that I've studied, when I say that to people, they sometimes get alarmed by saying, oh no, you mean the good stuff, right? You mean the good stuff, right? And I said, absolutely the good stuff. And I'm thinking, how can I rephrase that statement so that some people don't get alarmed by it? You know, science fiction is science fact waiting to be discovered. They want to know that we're not going to have harm come to us. Everyone wants to know that, right? They want to know that we're going to use tools to reduce pollution, to help each other meet each other's needs, right? For everyone to have their needs met. And that's what we're talking about. That's what this channel is all about. This channel is about learning, experimenting, sharing the experience of progressing towards a place where we can all feel safe with our needs being met and collaborating together to get our needs met, right? It's a collaboration. And that's where it's really about, is education and collaboration and value of life. That's a big emphasis. So going back to the transformer, what I thought of, I thought, well, what if I polarize the transformer before we put any energy in or out of it, right? What if I put a magnet at the bottom, a very powerful magnet, right? For example, I have these magnets here. These are magnets. Look how tall that is. So it's almost up to my, well, it's halfway up my arm. There's my hand, okay? See my hand? So it's 1, 2, 3, 4, 5, 6, 7. That's 7 magnets tall right there, stacked on top of each other, right? So this is, let's see how many magnets are here. 1, 2, 3, 4, 5, wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is 12. And I have one on the fridge over here. Right there. That's 13. And what if I put those magnets, what if I just set a transformer like this one on top of all those magnets, right? What if I set this transformer on top of those magnets? And then when the input comes in, and at the moment right now, I'm not sure how transformers work. I forgot, because I didn't refresh my memory on it. If they require AC or DC, right? And is there both? Is there an AC transformer and a DC transformer? But whatever normally makes a transformer work, what if I just put magnets to it? And also, look, gosh, I wish I had looked that up, because at the moment I don't recall. Let me think about this. Yeah, I actually don't know if a transformer requires AC. I would kind of be guessing, just a guess, that it requires DC, but I could be wrong. So will we change the AC into pulsating DC, just with diodes, right? Just a full wave bridge rectifier or diodes, switching that 60 cycles per second over to a DC 60 cycles per second, right? Which would be like a half wave, I guess, cutting half the wave off. And does that double the wave on the other side? Does that double the... I don't know. I mean, I'm just speaking my beginner thoughts here. But the idea is, just as a transformer works right now, the way it works, you know, putting magnets against it on the bottom. What if I put some half on the bottom, half on top? Does the output change at all? And just trying to power a transformer in different ways, right? So if it usually works on DC, can I pulse the DC? If it usually works on AC, Can I increase the frequency of the AC? Can I decrease it? Can I increase it? And use both AC and DC. Can I use both AC and DC? I don't know. I'm just thinking about the transformer. What can I do with it? Because we have iron and we have two coils, right? L1 and L2. I think that's what they call them. Now let's go back. So again, just thinking about what happens when we polarize, when we create a plus and a minus, or a north and a south, or let's see, a plus and a minus. Plus is south, I think, and north is negative, right? I mean, plus is south and north is negative. Yeah, I think that's right. So another thing I was thinking about, I think I wrote it here, is I think I wrote neodymium magnet, ferrous iron metal, or any magnet test different, I cannot read my own writing. Test different, I don't know what that word is right there. Let's see. Oh, test different magnets and metals. Yeah, also test aluminum and copper as well. Okay, so I was just saying, in place of this magnet, it has a north and a south. Try using a ferrous metal, right? Try using an iron that a magnet can stick to. Also try using copper, a solid copper, not just a copper pipe, right? What would happen if we used a magnet like this with the copper pipe over it, right? What would happen if I had a copper pipe over stainless steel? Don had talked about some experiments with stainless steel and how that was amplified. I think it was amplifying, right? It was an amplification process. I don't know. I don't know if I would do that right away. Again, the goal is just to get watts, right? To shake watts loose from the Dirac sea, the ocean of Dirac holes in space. You shake those electrons loose, right? And then they get filled up with the sun, right? The sun just fills them up real quick. I think that's where they come from. I think the sun makes them. I think that's what was being suggested in Don Smith's some of his lectures, and also a student from MIT who was said to be extremely knowledgeable about electrons and electron theory, or I'm not sure how to say the way he said it, but he was describing electron pairs as also coming from the sun. And they don't come out as pairs. They come out as some electrons are maybe larger than others, but in space, I think I'll say it this way, I'm using my own words, in space they kind of pair up by themselves. The large and the small will pair up. And when they're used as, when you pulse them, right, don't think Don Smith's work, when you pulse the electrons, they do a figure 8, right? And if you notice, that's the infinity symbol. And also the symbol on true zero emissions right now is that infinity sign, right, of the electron, the infinite electron. It's a fundamental particle. It never dies. It lasts forever. The electron just goes on and on forever, right? And it just will keep creating amps, volts, amps, volts, amps, volts as it cycles through that process of being shaken loose from the Dirac holes, from the Dirac sea. I'll call it from the Dirac sea, the ocean, Dirac ocean, right? The Dirac ocean of electrons. So I'm probably going to watch this video at some point in time and laugh at how I'm explaining all this, but that's okay with me. I'm just sharing my thoughts, and thoughts do not always make sense when they're being shared in the beginning. This is like a rough draft of my thoughts, right? Let's go back to this and see what's happening here. So when I was thinking about an alternator or a generator, it's using a ferrous metal with the coils wrapped around it, right? Now here Don's using coils, regular copper wire coils, not even a magnet wire, because magnet wire would probably be more efficient, right? I think it may be, but it also is more expensive and harder to get, right? I think we can use any copper wire, and maybe any wire here, possibly, because Don liked to make things in the simplest way possible. And he wanted us to know that things really are simple. But everybody says it's going to be hard until it's easy. So we just have to not give up, and that's what I'm doing. But again, if I spend my whole life studying this and nothing ever happens, I never can charge my scooter, I'm still happy because I learned. And I think some people are like, well, I want to see results. I have a goal. I want to see more out than in. I guess what I would say, just study particle physics. It's about learning day to day. It's about the creating of different ways of thinking about things. That, you know, the journey is the destination. So to me, it's all about the process. So the goal is right where I am right now. It's always where I am. That's the goal, if we say it that way. Someone once asked me, what's the goal? What's the goal of your channel? What's the goal? I said, the goal is to learn. It's to learn and to share what I'm learning. That's what I'm here for. So I'm going to look at this now. Now this tachyon G-field generator, that's what I'm calling it. John Bedini called it a G-field generator. I'm adding the word tachyon. I don't know if he used that word or not. It was mentioned in many places, 27 to 100 plus times the speed of light. What's taking place here, right? So let's look at what's happening here. Now, one of my first thoughts were, and this is probably something that a teacher, if I was in a classroom, would probably make them feel crazy or happy. Maybe they would get excited by this, what I'm saying right now. What I'm going to say is, what's another way of doing this? I'm going to say the most important thing about this right now. Two things. One is this is all one wire. This wire goes around there, connects over here, goes down, goes around here, and then connects here. That is a ring. Think of an alternator where when this thing's spinning, we can have something like brushes touch this, and that's how we get our energy away from here, right? Because the energy is coming through these coils. Now, these bars that the coils are wrapped with, if I recall correctly, it's been a while since I studied the videos and studied everything, but the metal that these coils are wrapped around are not magnets, but they are a ferrous metal, a metal that can be magnetized or can be polarized. I shouldn't say magnetized, but when it comes in contact with, well, let me say it this way, a magnet will stick to this. This is a metal that magnet will stick to. For this to work, though, and this is completely 100% necessary, and it was the #1 mistake that people were making when they would build these. This can be used as a battery charger, right? That's what it's used for. So even though we're calling it a spaceship motor, you can use it as a battery charger or a battery rejuvenator. And I don't know what else. Well, we know it's supposed to be a spaceship, something to do with a spaceship, right? But so this #1 mistake was this bar right here in the middle, right, where everything turns. It's the axis upon which this rotor spins. Must not be a magnet must not be able to stick to it. It cannot be a ferrous iron. It cannot be a ferrous metal. It cannot be something that the magnet will stick to. If it is, it won't work. This will neutralize the way the energy flows. It will not allow it to work. So people that were making these were using an iron bar that a magnet can stick to, and it was changing the flux direction. It was changing the way the flux fields were moving and redirecting them and not letting them flow at all the way they're supposed to. So let's now look how it works. So this is spinning, right? It spins. And we have on this side, we have a south coming into proximity, close proximity to this metal here. And we have a north coming into close proximity to the same bar. This is a ferrous metal right here. This one is. This is not a ferrous metal. A magnet does not affect this, but a magnet does affect and polarize this. So this I'm guessing this would become south. At the same time, this becomes north. I'm just guessing, right? I think when you put a south next to a metal, I think it becomes south as well. But whatever it becomes is what this is. So it becomes, for an instant, it becomes south and north, or north and south, whatever it does when you bring a non-magnet into contact with a magnet, but that can be attracted to a magnet, right? But it's not a magnet itself, but it becomes magnetized. In other words, if I touch this magnet to here, I could then touch a metal screwdriver, a ferrous screwdriver to this, and it'll stick to it, right? But then when I move this away from there, the screwdriver would no longer stick to this, right? So a lot of us have experienced that when we're working with things that are magnetic. So it's crossing these two, I'll call it fields, these two flux fields at the same time. And what? At the same time that down here, right, because this wire is connected, or see this wire going down here, connecting here, we have the opposite. So here we have south and here we have north, and then here we have south and here we have north. So these two sides are opposite. This side and this side are opposite, right? Flipped over. And then this side and this side are opposite. This side and this side are opposite. This side and this side are opposite. This side and this side are opposite one another. So we have all these, we have 4 opposites, right? Or we have similar, this is similar to this. This is similar to this. But look where the location is. So I was thinking about, okay, so I'm thinking, so now we're using something that's not a magnet. Where's the magnets though? There is magnets. These are the magnets. And the way it looked to me was the magnets were right here. And I don't think these were magnets. I think this was just a metal like this is. Right? This is a metal that a magnet will stick to. So I think this was being polarized by these magnets that were stacked on top of each other. Now this may or may not have been a magnet at the bottom. I don't actually know that. So you have to test it both ways. I would test it first with it just being a ferrous metal, because the shape of it, how it goes out like that, it could or could not be a magnet. It may or may not be. The important thing is the poles, what the poles are saying. I imagine that if this was a magnet, it would just be stronger here. And I know that when this thing turns, it's very noisy because it goes thump, 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 right? It's when it passes this area, it goes thumps. It thumps, makes a thumping sound, like a vibration sound. And what else? Let's see. When do you think the energy is coming out of the wires? Or going into the wires and coming out of the wires? That's instantaneous, right? Do you think it's when this comes into contact with that magnet, when it comes there? I don't think so. I think it's between the 2 spaces. So now we're back to the less is more again, right? Imagine if this system had these next to each other all the way around in a circle, right? So if that was the case, though, because this is the opposite, half of the circle would have to be all souths on that, and this half, the other half would be all norths, and then the bottom would be the opposite, right? All souths halfway, and then all norths halfway. Or back and forth, I guess. I don't know. This is the way it's made, so I don't know how this could be varied or modified. And I think it had 2 of each of these. So I think it had this, and then probably this here on this side, and then this again there, and then this, whatever's on this side, the opposite on the other side, right? So there was 4 of these, if I recall correctly. But even if there was 2, I think it would still work, as long as this is right. That's what matters, right? Is that the polarity be correct. But if we look at what's happening, it's the opposite. It's 2 opposite fluxes. And I think what's happening now, I think it was described as the energy pumping in through this, right? Well, that's where the magnets are. I mean, that just makes me think that just looking at this, if it's true that the flux field is moving right here, I would think that wrapping some coils around this would be highly, highly effective, potentially. And maybe give us a lot of voltage, possibly. I'm just guessing. That's a guess. I'm just thinking of, what's happening here. We have, I don't know. I just wanted to say that. It's just a thought experiment. Is wrapping this. So this still does what it does, right? I think he was getting 600 volts out of this. I'm not sure, though. I don't recall correctly exact numbers. And it depends on the wire you're using. These coils were probably at least a couple of 2 or 3 inches in diameter, each one of these. I think. No, they weren't that big. They were like 1 inch or 1.5 inches. He had different designs that had larger coils. That was a totally different design, though. And I have it drawn here somewhere. I could try to show it to you. Let me see if I can find it. Okay, I don't know what we call this, but this was just another design where I think that these bars here are a ferrous metal. I think this shaft must not be a ferrous metal. We have the magnet, one magnet with a north and a south, and what happens is this rotor just spins. This magnet spins really fast. And I think these had really big coils, like 2 or 3 inch coils on them. I don't know what this is called. I don't know if I wrote the name down. Oh, it was also called the tachyon wave battery charger. There might be some unrelated. Yeah, that's my iPhone glitching. Got some notes for the next day. Charge batteries. So this charges batteries at 27 to 100 plus times the speed of light. I think that's what I said there. And again, you have to confirm all this for yourself. non-ferrous. See how I said non-ferrous right there? That rotor must not be a metal that a magnet will stick to. It must not be that, or it won't work. You know, people make these things and they use a ferrous metal and they go, it doesn't work, it doesn't work. And the question is never, does it work or not? The question is, what is it doing? That's my question. You know, that's what I want to know. What does it do? What is it doing? What's happening? So here we just have these two ferrous iron bars with copper windings on it. And we're pulsing. Now, wait a second. I don't know if I'm missing something here. Looking at this right now, because it was dark when I was in the video I was watching. It was dark when I looked at this. So right now, with what I've learned, I would say that what's needed to make this work is to have the same magnet but reversed on this side, so that these two bars are being pulsed with the opposite polarity on each side. So a north hitting this side and a south hitting this side at the same time. Bam! And then this coil is going to do what it does, right? And this one too. But it could be tried both ways. It could be tried with just one magnet and see if anything happens. See what comes out of these coils. And then put another magnet over here that is in direct, that directly hits is at the same angle, so that it comes across these bars at the exact same time as this one, but down here, but be opposite, right? So we have south and north, and then here we have north and south, where the magnet spun like that. That's my thoughts on that. That's a different design now. So one of my thoughts was, I'm thinking about alternators, and I'm thinking, well, alternators, I know I keep saying this, but I'm going to keep going back to it, and I'm trying to revisit this in new ways of thinking about it, and new ways of reconsidering what I'm saying. Alternators they don't have magnets. They don't even have magnets in them. Alternator has an electromagnet. You put energy into it. So I think we put DC into the magnet. I mean, into the coil that's on the rotor. And it magnetizes or polarizes the rotor, right? And it makes it north, south, north, south, north, south, because it has a coil. I think it has two coils in it. One coil's north, the other coil's south. So they're probably wound in opposite directions or powered in the opposite polarity to one another, which allows them to, one be a north, one be a south, or one be a minus and one be a plus, if we say it that way. And then as that spins, as that rotor spins, the outer coils, right? The outer coils kind of look like this. On an alternator, it does kind of look like this. In an alternator, it'll look something like this, right? An alternator kind of looks like that. And but instead of this here on the rotor, because that came from there. Here though is electromagnets, and it's the same thing though, north south. But I thought, why didn't they just use magnets? Maybe it costs less to use electromagnet instead of permanent magnets, right? Maybe that just costs less. I don't know. But on an alternator, it looks similar to this on the outside. I'll call it the stator. I think that's the right word because it stays still, right? Rotor rotates, and this part doesn't move; it just stays there. So as the rotor's spinning on an alternator, now these, I'll call these legs or fingers. I don't know what they call them. I think they use one of those words, possibly, maybe other words as well. But these are all iron that when the magnet goes to it, it becomes polarized. And it's going to be switched from plus to minus, or north, south, north, south, north, south as the magnet passes that. So these are all getting switched from north, south, north, south, north, south, you know. But what they're not doing is they're not doing it at the same time. I feel like everything I'm studying is telling me that an alternator, to be more efficient, however many magnets there are, should be the same number of these. There should be the same number. That's just what it looks like to me, right? To not do that is to ignore a lot of research. And I don't do that. I don't ignore research. I don't ignore it. I pay attention to it. I apply it. This is applied research here. This is what this channel is about. So, Gerard Morin said this. He said, if I recall correctly, Gerard Morin said we want the same number of magnets and the same number of these, right, coils. And Gerard Morin also talked about experimenting with both copper coils without iron and with iron. Like he said, try both, right? And I think he was a fan of no iron. as well. But because these systems are using iron, like this has to be a ferrous iron, right? These magnets, I don't even think these were neodymium magnets. I think these were just regular magnets. Like when I say regular, I mean something like this. See these? They kind of look like these, but probably more powerful, maybe better. Or not, maybe not. Maybe they were just like this. Maybe it's the same thing. Those ones. Not these. These are neodymiums, but these up here. Yeah, these are like, I don't know what you call these, like refrigerator magnets or something. These are not very powerful ones though. I do think it's important to have a strong field there, a strong magnetic field. But in that particular design, in this one, in the G-field generator, these were not even neodymium magnets. They were not neodymium. How amazing is that? And we're getting these kind of speeds out of there. Whatever that means, right? I don't know what that means. What's the speed? Is it the speed of signal? It's a gravity field generator. That sounds like anti-gravity to me. So if I run the output to 2 plates, would it do something? Would the plate start levitating? I don't know. That's the first thing I think of. But just the fact that that was said, it kind of is interesting to me. So I'm going to think about it as I read other books. I'm going to keep that in my mind and see how everything fits together. And I especially look for when someone says, don't try something or something's impossible. I write all those down and I go right for them. How can these be done? Right? Because someone just accepts that something can't be done, and it certainly, what are the chances that they'll achieve finding a way to make it to be done, right? Because we have to be open to thinking about how something can be done, right? I mean, that's how we move forward. That's how we move forward with knowledge and with theories. So, yeah, so on this one, if I had a choice, I would have the same number of magnets as there are. Well, I guess that could be done. I would have to, it would probably be much easier just to change the magnets and make that number match that number, right? So however many of these there are, let's see how many of these are. There's 1, so I'm going to start here from the top, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 of these, and let's see how many magnets there are. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 magnets. So I would take those off and add 4 magnets, which means the magnets would have to be smaller. But it would match. It would match that. And I would keep the north, south, north, south. You know, it almost seems like I have magnets that I might be able to do that with. Here, let me see. I have these really small magnets that come from like electric outrunner motors, like these. Now these aren't perfect. This is not perfect, you know, at all. But I'm not talking about perfection. I'm talking about experimentation here. I don't know if there's 12 of those there, but if there is, I could do that. Let's see, 1, 2, 3, 4, 5, 6, 9, 10, 11, 12. But I don't know if those are all the same either. Let's see. No, those are different. Do I have 12 of the same magnet? That's the question I'm having right now. 1, 2, 3, 4, 5, 6. Let's see how many these are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have exactly 12. There's enough there. Now, these are very small, right? But I could try JB welding those. Oh, look at that. Wow, those are really... That was actually dangerous what I just did, because these are both neodymium magnets. And this I could have just broke those, and it would shot metal out. I have glasses on though. So yeah, it's really interesting. I really like magnetic fields a lot. I like magnetism and flux fields. Very interesting to me, especially the Bloch wall. Felix Bloch research, Nobel Prize winner. I'll be studying everything I can find on him. Yeah, that might be a test, but I don't really want to damage this rotor. I have other motors like this, so I could take one of them and take it apart and do that experiment. But that's just one possibility. That's just one. I just smashed my finger with the magnet a little bit. Hold on 1 second. that whole row of magnets went past the big one that's on the refrigerator, and it hit my thumb against it right here. It just made it red. It didn't cut me. I got lucky. The magnet was in my hand, and it smashed this finger against the big magnet, because magnets want to attract together. And you saw how small those magnets were, but they were small magnets, right? So the bigger ones are even more dangerous. And people have crushed their fingers, like crushed the bones, just crushed them. And then they healed it through using, I can't think of the name of the tool right now. I'm going to make a playlist of it, though. It's like a violet, I don't know if it's called like a violet ray machine or something. It's like a light. You use a light and use arnica on your finger, and this light, which I think is used, I was told it was used in beauty salons a lot. And you use that light at slow increments, just a little bit, not too much. And it can help heal the body, right? I'm interested in healing as well. You see my reversing aging interest sometimes as I write about it. That's Aubrey de Grey working on that stuff. It's relevant because the more that longer we can be here in health, is the more that we can share and build together, right? Build communities, build ways of helping one another, and build bridges throughout the universe to extend our interest in community, collaboration, and peacefulness, right? But we certainly have to achieve it first here. Let's work on that. I think we are. I think we're doing good. We have to keep doing that. We have to stay on that path. I know the road's rough, but we can do it. I know we can get there. We don't have a choice. We have to. We have to work towards peaceful living among all Earth. Everyone on Earth has to be able to work together and not fight. Okay, so let me think what I'm thinking about right now. So I was looking at this system here, and I'm thinking to myself, what if these coils, instead of being wound around a ferrous metal, which is a metal that a magnet will stick to, right? What if they were wound around magnets, right? So what if these were each magnets, right? So now I'm talking about making my own alternator, right? Or generator, whatever you want to call it, but we'll call it a pump. I'll just call it an energy pump. That's what all alternators and all generators are, is they pump energy from the environment into the circuit, right? That's the way I think of it. That's the way I see it. It's pumping it from the Dirac sea, S-E-A, right? Isn't that where all energy comes from, the Dirac sea? So we can also call it the zero-point field. We can call it tachyon waves, gravity waves, and virtual particle flux fields. I think there's a relationship between all those words I just said. Time will help me understand the relationship. So, but fundamentally there is no time, right? So all time and space exist within every instant as well. That's just how it looks to me. But looking at this here, if this was a magnet, if each of these were magnets, right? And then my rotor had a magnet as well, and one magnet for each magnet there, right? So it has to be the same number. So if there's 12 magnets there, and these coils are wrapped around magnets, right? And then there's 12 magnets here, and it's the same thing, north, south, north, south, north, south. What would that do when I spun it? That's what I'm wondering as a thought experiment. And if I could find someone to build such a, I'll call it a generator. I'll just use that word because that's what we think of as we think of a generator, right? But we know it's not making energy, it's pumping energy from the environment. Even though it's the way it's worded, like if we look up on Google and say, where do electrons come from? Every time I've looked at that in the past, it's just, I never have an answer. I feel like I'm going in big circles. I feel like it's like a circular definition, right? Which teachers tell us that's not what we're supposed to do. You can't do a circular definition. You can't send people in circles. But that's what happens in energy. Everything with energy, I'm always going in a circle. I'm never getting anywhere. So what I do is I step out of that circle, I step out of it, or I don't even go in it. Or as soon as I go around once or a couple times, I see it's happening, I step out, and then I take a bigger picture. I look at everything. I look at particle physics. I look at what are all the people that I study or that are talking about energy. What are they saying? What did they study? And what do they recommend to study? And then study both. Study popular theories and study unpopular theories. My teachers always said read everything. That's what they meant by that. I think they meant read everything. Literally, read it all. So here we are today. And thank you to all my teachers that encouraged me to learn beyond. So yeah, that's one idea there, you know, because we're talking about magnets here, right? But here we have the magnets are over here and there's no copper wire around it. And look at all the activity. Look at what this does. Is this more efficient? Is this more efficient? What's the difference? How many watts does this put out? I don't think this is about wattage though. I don't think this is about watts. I think this is for watts. Well, this being the Don Smith rotating separator coil. This is just a variation, experimental variation of it. That I don't even know if this will work, but I want to try it. But this is using the magnets over here, and it has the copper over here. So then I think, well, wait a second. Here we have this ferrous metal with windings on it being pulsed at opposite polarities. How can I replicate that with something like this? And maybe that's what I was talking about earlier, right? With the north-south, 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 having the same number of, well, maybe I can just make the request. Anyone that makes alternators, please make an experimental version, right? Because you have all the tools. That could just be used for experimenters, right? That has the same number of magnets and the same number of ferrous iron. And let the experimenting begin. If that was made available as an experimental, as like a contribution to science, then we have to buy it, of course. We would buy it from any company that made that. But it would be nice if companies that make alternators literally make them and machine them. Or if someone that does machining could make this and then just sell it as an experimental only. No claims. No claims of watts or how much power it makes. Just the specifications would be, you know, that there's the same number of magnets and the same number of coils, and that these are also magnets. You can make it both ways. One way can be that there's iron there. The other way can be magnets. And if I had to choose between the two, I would say go with magnets. Magnets being there. And also make different rotors. Like some rotors could have, well, maybe that gets too complicated. Maybe to start out with, just do that and see if they sell. And if people buy them to experiment with no claims made, you know, then move on to the next experimental thing, which would be probably using less magnets, right? So a north and a south. So north, south, let's see, north, south, north, south, right? So north, south, north, south, north, north, south, north, south. Yeah, that would be neat. It'd also be neat to have north, south, north, south, right? So north, south, north, south. So these two are north, these two are south, and then have this where it's that wired that way too, where there's 4 coils, and they're real big coils, right? And have them do a variation of this, right? But maybe it would just be like half of that, I guess, right? Like half of that, I guess. I don't know. I'm not sure if there'd be a way to replicate that exactly. This kind of the signal hitting 4. You know, 2 opposites and 2 opposites. How would that have to work? I can't imagine it at the moment, but I'm thinking north, 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 south, south, and then the coils would be 4 coils, and I'm not sure how they'd be wired. Maybe the wires of each coil could come out the side, and then we just wire that up any way we want to. I think that's the way to do it. So the coils, there would be 4 big coils, right? 4 big coils, and the wires just come out, and then we wire those together in series parallel, or you know, let's see. Well, let's see. This one has the north and the south hitting at the same time, so I guess, yeah, I don't know how it would be done. It'd have to just be experimented with, right? Because there's different combinations of ways it could be done. That's just a thought. I mean, I know businesses are in the market of just making things a certain way for popular demand, right? And experimenting might, I don't know how much of the industry that takes up, but it's just some thoughts I had. It's a thought experiment. So anyway, I think this video is long enough. It's been an hour. It's probably going to take a few days to upload, although my uploads have been going faster recently. I don't know why. After I said they were going slow, suddenly they exponentially sped up because it was taking days or a week or 2 to upload, and then suddenly it took an hour to upload for the same length of video. Isn't that amazing? All that happened is I said, my videos are taking so long to upload, and then they just went faster just by saying that. How does that work? I didn't change anything. I didn't do anything or change anything. They just started uploading within an hour or 2 versus 2 weeks. But however that happened, I'm grateful for that. Very happy. I may be having a very large Wimshurst machine at some point in time, within the next 12 months. I may be getting a Wimshurst machine that's going to be fun to experiment with as well. I'm also excited about that. So I already have one, but I thought maybe I could get a bigger one, and it would be fun to experiment with, because I sure enjoyed the one I have, and it's just been a great joy to experiment with and do things with, and just to watch those big sparks come from the environment just by spinning 2 discs intermittently with intermittent conductivity, right? Intermittent conductivity, spinning in opposite directions in space, right? And I haven't read one explanation of how it works that made any sense to me, not one. When I just look at it spinning, what I see is counter rotation and intermittent conductivity being stored in capacitors. So I think, because my brain just wants to look at things in a simple way, right? So that's what I see. I see counter rotation, right? And I see intermittent conductivity, right? Because there's the conductive metals going around the discs, right? I mean, that's it. So I'm trying to think, how does that apply? How can I apply that the idea of counter rotation to both anti-gravity and to charging batteries? It's just some thoughts. It's some thought experiments. It's fun to think about. Okay, everyone, I'll sign off for now, and if I can think of anything else, I'll surely be making another video. But this is just some thoughts I had today, and I think I covered everything I wanted to, plus more. And we'll see you in the next video. Okay, bye everyone. True Zero Emission signing off. We'll see you in the next video.